Dear students, welcome to Sia's digital classes. Today let us discuss some problem based on Poisson distribution. So Poisson distribution problem you may expect for long type or sometimes short also you may get. So right now what we are discussing this problem you can expect for long type. So let us check it out. Here is a problem. Fit a Poisson distribution to the following data. They'll give some x values, they'll give some f values, that is frequency values, and here e power minus m value also they have given, e value you need to remember I said, so e power minus m value they have given here. So let us check it out where it is utilized and all. So first let us discuss the formula, then we'll come back for the table. So formula, probability p of x is equal to e power minus lambda power x by x factorial we know earlier we discussed the formula. So here we'll be using that under recurrence relation. Recurrence relation means if it is repeated again and again, like check it out here, 0 to 4, 4 times, 5 times we are considering. So we'll change this formula to recurrence relation. So recurrence relation formula is here, it goes on. So while doing the steps I'll explain what is that again. So to get that recurrence formula I need lambda value, check it out here. Everywhere lambda appears. So lambda we need to find out through the table. Lambda is nothing but a mean of Poisson distribution. Mean formula we know for discrete data, mean formula is summation fx by n or summation f. The same formula what we have learned earlier, mean formula itself, but mean is represented as lambda in Poisson. So lambda is equal to summation fx by summation f we need to consider. Now to obtain this fx and f we have to go for the table. Then we'll come back for the Poisson substitution and all. So here is a given table, x value they have given, f value they have given. First let us do summation f, that is adding all the f values. So 123 plus 59 up to the last you add up, you got the total summation f is equal to 200. So generally we'll consider as n also you can consider, anyone is the same. Next I need f into x column, that is simply multiply f values with x values. So 0 into 123 is 0. Like that, multiply each value of x column with f column, that is 1 into 59, the second value, 1 into 59, 59 itself. So like that, multiply x and f values and get its total. So I have got the total as summation fx is equal to 100. So here we got all the totals. Let us consider lambda and get the value for it. So lambda is equal to 100 by 200, that is 0.50. I have obtained the value. Now after obtaining lambda, let us go for getting the values for p of 0, 1, 2, like that. So p of 0 is nothing but first value of x, check it out, x starting from 0 we have 0, 1, 2, right? So that all values we need to obtain individually for Poisson. So probability is p of 0. For first x is equal to 0, p of 0 is directly the given value whatever they have given in the question. So e power minus m they have given, right? So that is a first value. So that value I have considered here directly. Now that I'll utilize to obtain all other values. That is next p of 1, x is equal to 1 whenever you have, its a probability p of 1 is equal to p of 0 into lambda by 1 becomes a recurrence relation formula. So nothing but simply p of x value, p of previous value, p of x into lambda by x value. So that is p of x plus 1 is equal to, if you want a generalized formula, this becomes the formula. Here directly substitutions I have done, means recurrence means upside one will be reusing, next reusing. So that is your recurrence relation formula. So I have p of 0 already I have in my hand, that is 0.6065 substituted into lambda value I have done earlier 0.5. So substituted by 1 will be doing, we'll get the answer here. Similarly, P of 2, when x is equal to 2, we have to do, that is P of 2 is same formula. So, before value we will consider, right? So, P of 1 into lambda by 2. So, substitute and get the answer. Similarly, until the last value, you have to go on doing a recurrence relation and obtain all the probabilities. So, after obtaining the probabilities, in step 3, what we do is, we'll obtain f of x frequencies will obtain. So, how to do that? Let us check it out. So, after obtaining all the probabilities, I am taking the table again, x values again in the first column, given question x values in the first column. Second column is p of x, that is right now what we have obtained, p of 0, p of 1, that all values resubstitute here. So, check it out. From that values, I have rewrote all the things here. Next, what we have to do is, we have to do f of x column, that is expected frequencies will call. So, these are the observed frequencies, given data, and given data whatever the f values are there, those are observed values. Now, we have to do the expected frequencies. So, expected frequencies formula is f of x is equal to n into p of x. N we know, summation f is nothing but n we have learned in the previous sum itself. So, summation f total whatever you have, take that as the capital N value and multiply with each of the probabilities. So, check it out, 200 into p of x we have to do. So, p of x here we have, so 200 into that p of x value you do. So, 200 into p of x value you do, will get f of 0, first value, which is approximately we are considering as 121. We need some approximate values. We will compare with observed frequencies. For that, I am considering approximate values. So, next for f of 1, you substitute the values, that is 200 into the second probability value 0.3032. So, I have got some answer. Approximately, I have considered it as 61. Similarly, consider all other values of this last column and find out its approximate values. Now add it up, all that values, 121 plus 61 plus 15 plus 3 plus 0, that goes to 200. So check it out, whatever the capital N value total of frequency you got, exactly expected frequencies also we got the same, that is N is equal to N, or summation F is equal to, here summation F we got. So, whenever we do Poisson distribution or binomial distribution, whichever distribution you are trying to do, we'll try to get observed frequencies exactly equal to expected frequencies. That we have achieved here. So, this is how we'll do the Poisson distribution problem. Check it out. I have wrote here all the answers, x values and the expected values, whatever we have obtained in the last column. So, this is how you'll solve the Poisson distribution problem. So, hope you have understood this session. See you all in the next session. Thank you.